Hello everyone, this is Sainath and today's seminar topic regarding probability and statistics is difference between one-tail and two-tail test along with the test hypothesis for single and difference of proportions with an example programs. Now we're going to discuss these two topics. Difference between one-tail test and two-tail test. When you take one-tail test, the rejection area is at one side of the diagram so that in the picture you can see below, which explains in the case of one tail test, the rejection region will be located in only one tail, either in left or in right, depending upon the alternative hypothesis. This is illustrated in this picture. When you look down the first picture, it gives one tail test right. So the rejection area is at right tail. So when you see here, the acceptance region of left side is 0.50 and right side the acceptance is 0.45 and we have rejected 0.05 as it is right. In one tail test, we have right tail and left tail rejection regions. So when you look at the second diagram below, the left part, the left tail is rejected. So the acceptance regions of right is 0.50 and the rejection region on left is 0.05. So the acceptance region in left is 0.45. Now here it is given alpha equal to 0.05. So that is the rejection area. Now let's look at two-tail test. When you look at a two-tail test, it has two tails having the rejected region and the acceptance regions is cutted off by the tails. When you look at the first diagram on the top, you can observe the rejected region in on both sides. So it is called as two-tailed test. And the acceptance region is 0.495 and 0.495 on both sides, in which the rejected region on both sides is same 0.005. So this is regarding the difference between one-tail and two-tail test. Now let's see how to identify a problem which is one-tail or two-tail. Let's see the technique of identifying one-tail and two-tail test. Firstly, using one-tail test, we can have these keywords like less than, more than, greater than, smaller than, taller than, superior, inferior, increase, decrease, at least, at most, only improved. But when you use two-tail test, you have no specific keywords. Now let's see the hypothesis for single and difference of proportions with an example problems. Firstly, we discuss about test of significance for single proportion. For this, we have five important things. First is null hypothesis H naught. Here P is equal to P, that is populations. There is no significance difference between the sample proportion and population proportion, or the sample has been drawn from the population. So here it is giving that the sample population and the population proportion has no significant difference. So it is given as P equal to P, that is null hypothesis. Next, let's go with alternate hypothesis, which is H1. Here it gives the sample proportion and population proportion are either not equal, less than, or greater than. So here we can see P not equal to P, P less than P, or P greater than P. Now, level of significance alpha is the level of significance which we before saw like that 1%, 5%, etc. And now let's take the test statistic. We have here the formula Z equal to P minus P by square root of P cube by N. Here the P's are the sample population and population proportions and N is the total population. Now this is the test statistics and we can, by this we can give the conclusions that we can accept the null hypothesis or we can reject the null hypothesis by accepting the alternate hypothesis. So what is actually the level of significance? Let's see once again. This is the previous slide which we have discussed, and here it is given if we test a hypothesis at 1% level of significance. So here the level of significance which we discussed before, the third important point, it is given as 1%. So for 1%, the diagram illustration of two-tailed test is given here. We discussed about the rejection region and acceptance region. For two-tailed test, there is two rejection regions, and for one tail, it is only at one tail end, that is either right or left. Now let's see the critical value table. So here given the critical values on using the normal probability table, in which you can have critical values, and before we discussed level of significance, that is 1%, 5% and 10% here for two tail test, right tail test and left tail test of one tail test. Here some values are given according to the significance value. So we take the values like that, and now let's discuss the examples about the hypothesis test on single proportion, which I have discussed earlier. So let's see some example problem. Okay, now here is the first example, and let's read the question. A die was thrown 9,000 times, and of these 3,220 yielded 3 or 4. Is this consistent with the hypothesis that the die was unbiased? So here we got a problem in which the die was thrown 9,000 times, in which 3,220 times it is given a 3 or 4. Now we have to make a hypothesis, thus the die was unbiased. So let's see how to check it is one tail test. Okay, now sample size, here we have total size n 9,000 sample, and the sample proportion is the outcome by sample size. So 3,220 by 9,000, 0.3577. Now population proportion. So we can get here, they say the yielded 3,220 are either 3 or 4. So if we throw a dice for getting a 3 or 4, we have the probability of 1 by 6. So for 3 or 4, so 1 by 6 plus 1 by 4, 1 by 3, and it is 0.33 bar. So here, if P is 0.33 and we can get Q, that is Q is equal to 1 minus P. So 1 minus 0.333. So we get 0.66 bar. And here null hypothesis. We already discussed that P is equal to P. So sample proportion is population equal to population proportion. So P equal to 1 by 3. And alternate hypothesis, that is P not equal to P. Here, if you observe, population proportion is 0.333 and sample proportion is 0.3577. So both are not equal. So here in alternate, it is given P not equal to 1 by 3. And let's check the level of significance. Now, the alpha is taken as 0.05, which is the rejection area, and the alpha by 2, 0.025. And if we take alpha minus alpha by 2, we get sorry, if we take 0.5 minus 0.025, we get 0.475. 0.5 is the acceptance area, and 0.025 is the rejected area on single tail. Now we get 0.75, 475. For 0.475, we get Z tab as 1.96. So let's check the test statistic with the formula P minus P by square root of PQ by N. After the formula, we getting the test statistic as 4.9108. Now from the conclusion, we got that calculated value. That is, when we calculated by using a formula, we got 4.91. And if we get a tabulated that is Z tab, it is 1.96. So here calculated value is greater than the tabulated value. So null hypothesis is rejected. Now let's check the second example of single proportion test hypothesis. Now in a big city, 325 men out of 600 men found to be smokers. Does this information support the conclusion that the majority of men in the city are smokers? So here we got the information as sample size n is equal to 600 men in the city and sample proportion p is equal to 325 by 600, which the men we found to be smokers. So sample proportion we get 0.5416. In previous problem we have the condition like the dice rolled as 3 or 4. So here there is no such rule. And in a city, most probably there will be two genders, that is male and female. So let's take the population proportion P as 0.5 and Q as 0.5. So null hypothesis P equal to 0.5. And when we take alternate, we have to give P not equal to P or P greater than or P less than P. If we consider right tail test, P is greater than 0.5. So next, level of significance. We find this level of significance by taking away the rejection region, and we get the tabulated value as 1.645, and the test statistics, if we calculate it with the formula, we get 2.0379. So finally conclusion, calculated value is greater than tabulated value. So null hypothesis is rejected and alternate hypothesis is taken, which is the 325 men can be smokers. So null hypothesis is rejected. Now let's take a look on the difference of proportions, test of significance for difference of proportions. Here we have five important things as before. That is null hypothesis. Population 1 is population 2. There is no significance difference between the proportions of the samples or proportions of population, which is exactly same as before. And alternate hypothesis, that is given as P is greater than P or less than P. But here it is only the proportion 1 is not equal to proportion 2. That's it. And level of significance we can give by the, before we discussed about the critical values. And test statistic, here we have a formula. When the population proportions are known, so we know P1 and P2, so we will go with the formula as Z equal to P1 minus P2 by square root of P1 Q1 by N1 plus P2 Q2 by N2. If P1 P2 are unto, so unknown, we do not know the proportions, but we know the sample proportion, small p1 and small p2. Then we go with the below formula, that is Z is equal to small p1 minus small p2 by square root of p1 q1 by n1 plus p2 q2 by n2. And the alternate formula is given. So finally conclusion. If modulus of Z less than Z alpha, we accept null hypothesis H naught. If Z mod is greater than Z alpha, we reject the null hypothesis, that is accepting the alternate hypothesis. Let's discuss the first example. In two large populations, there are 30% and 25% as fair-haired people. Is this difference likely to be hidden in samples of 1200 and 900 respectively from the two populations? Here we got two populations as sample size, N1 1200 and N2 900. So first one proportion is given as 30% and second proportion is given as 25%. So here there is two proportions, so we can take it as the difference of proportions, and the 30% is taken as 0.3 and P2 is taken as 0.25. So here we know P1 and P2. So for null hypothesis, P1 is equal to P2 and null and alternate hypothesis P1 not equal to P2, which is by the formulas, and level of significance by calculation we get tabulated value as 1.96, and when we test using the formula Here we discuss two variations in formulas. So here we take the first one uh, by which we know the values of the two proportions. That is, we know P1 and P2 values. So we take the first formula. So Z calculated equal to P1 minus P2 by square root of P1 Q1 by N1 plus P2 Q2 by N2. So by calculating, we get 2.5537. So here Z calculated is greater than Z tabulated. So null hypothesis is rejected. Okay, now let's to move to the other problem. In a city A, 20% of random sample of 900 school boys has a certain slight physical defect. In another city B, we have 18.5% of random sample of 1600 school boys has the same defect. Is the difference between the proportion significant at 0.05 level of significance? So here we got two cities samples, and N1 is 900 and N2 is 600, which the sample and here proportion, that is 20% of the sample. So that is 20% of 900, which is 20%. So 0.92, and P2 we have 18.5%, so 0.185. Now we calculated the P value as N1 P1 plus N2 P2 by N1 plus N2. We got 0.101904 and Q as 0.8096. That is, here P is equal to 1 minus Q, or Q is equal to 1 minus P. Now null hypothesis, P1 equal to P2 and alternate P1 not equal to P2, and level of significance here, they already given the significant at 0.05 level. So for that we get the tabulated value of 1.96. You can check it on the tables. Now here when we calculated the test statistic, we got 0.91692. So here calculated value, that is 0.91, is less than the tabulated value 1.96. So null hypothesis is accepted. So this is regarding the seminar of test the hypothesis for single and difference of proportions with example problems. And we already discussed the differences between one-tailed test and two-tailed test. Thank you everyone for listening the seminar topic with patience. And this is Gaurav Venkata Sainath from Mugivara Courts. Thank you very much.